To showcase what we've been doing. We've got people coming to talk about the policy angle, we've got people coming to talk about the technical angle, we've got people talking about the path from science to innovation from both the social science as well as the sort of more scientific angle.
I think the day was enormously successful because I think it made a lot of the researchers in quantum computing really see for the first time perhaps what it is that we're trying to do. We've been interviewing them along the way about what they thought were the positive and potentially negative impacts of quantum computing. But today I think because we brought industry together, we had the policymakers there as well, we had Tom Rodden from DCMS, and the consequences of some of the technologies that have gone before, for example AI, machine learning, some of the more negative impacts that have happened on society because of those. I think they've suddenly realised why this is very important to take into account, and that responsible innovation as a broader programme than simply the ethical.
This technology is a radical change from current generation computing based on completely different principles, and Bill Phillips' note or statement is that it is as different from a current generation computer or anything we can conceive of based on that technology as a conventional computer is from an abacus. The important point is that it is not that quantum machines will improve a bit on what you do here by moving things along faster. It is rather that there are certain problems which, when you scale them up, are completely impossible to do on any conceivable conventional computer and become possible on a quantum machine.
So these are the two milestones that achieve and make all of us excited. We have now quantum devices, Google 72 qubit, which actually the supremacy was announced with their 52, 53. So I always say that what we are in quantum, we have the quantum ENIAC machine and quantum ARPANET. This is at the level we are. They are out there, they are doing something. They're not necessarily yet internet, they're not necessarily universal machine, but we have this massive, powerful quantum node and quantum link. And I like to somehow say NQIT is a bit of both, because we have both regarding the communication and networking architecture that people have in this room have worked on it, as well as the quantum node. So essentially you can see it from the both point of view. And that's where we are, and it's making quantum era and all the excitement that goes with it. So what I would want to discuss is like the vision that some of us share, that what would be the future of our communication and computation network. It will be a hybrid, nothing is going to be replaced. We're not going to throw away classical internet because it's going to be replaced. No, we'll have the classical communication, quantum communication, satellite link, some quantum devices, some classical devices, some quantum Apple Watch, some massive, etc. But this is clearly that we would have a hybrid network.
I think quantum presents a rich field of inquiry for scientists. The question is, are our eyes fundamentally grounded in the practical, in the real world applications and impact of technologies? The question is, how do we remove the hubris and actually get down to the real essence of what quantum technologies can and cannot do? If we can get to that point, we're then in a position to actually do something about the negative connotations, but also to maximise the benefits.
I think what came over to me was the real need for an overarching framework for research and innovation at the national programme level. I have no doubt that industry itself, most businesses already have frameworks, guidelines that help them conduct their business, but something that helped join together the ecosystem, the community, I'm sure would be very beneficial.
Although often technologies emerge with kind of compelling visions of urgent and beneficial change, it's very difficult to anticipate outcomes. And why? Because there are many development pathways possible, there are many actors shaping and reshaping the technology, and the social outcomes are only fully materialised when the innovations become implemented and embedded in society, so they come at the very end of this long process. As a result, it's very dangerous to try and extrapolate from those early visions. I remember when lasers first came in, we were clear about what they meant. They were developed by the military, they were death weapons from space. And then later on, they became things to threaten a spy with, very secret things. But nobody at that stage saw the real implications of lasers, which is the ability to price the carton of strawberries as you go to Tesco's each weekend. And I think what's interesting about the quantum world is the degree of internal controversy amongst quantum scientists and between quantum scientists and quasi-quantum scientists and some supercomputer people. So let's focus on that informed debate between people and use those insights to begin to interrogate the claims and also the possible time frames.
What I really want to talk about is the importance, I believe, of a framework for responsible research and innovation in the quantum area, not just from the research point of view, but to industry as well, learning from what we've seen in other technical areas. Ethical considerations are essential in AI and indeed it will be in quantum as well. BT has its own internal framework for doing this. Indeed, it's founded on human rights. That's our basic principle. We do believe it should be grounded in human rights rather than sort of making stuff up. But my concern for a little while has been that the focus on ethics has been masking what is frankly a lot of bad practice in the use of technology. Full stop. It happens to be AI, but actually if we look at what people are doing, this just isn't the way you go about testing out and deploying new technologies.
Certainly, I think one of the reasons why I'm here today is to point out that I think most of the public policy implications for big and open data I think are also very relevant to areas such as human-centred computing, quantum computing, predominantly because this is a new and emerging field that has a huge number of future public policy challenges and opportunities associated with it.
In terms of a government position in this, I mean, foundationally this is about promoting and encouraging, supporting innovation and the values to accrue from innovation. I think we need to think about building a vibrant community that's open. We need to think about a skilled workforce, and we need to think about governance from the outset rather than at the end, and think about how we put this in place. And ultimately underpinning this is to really think about parity and fairness and how we think about that throughout this. I'm quite keen that we start as early as possible thinking about governance in all these forms, and I don't mean this as a specific or particular issue for quantum. I think it is for most technologies. We often think of government after the event rather than from the start. What do we know from existing and previous models? What do we know from AI? What do we know from nanotech? What do we know from GM foods? These have all had issues of governance, and we really probably want to try and remember a bit of the history before and think about, well, what's the equivalent of what happened there in quantum space, and to do that from the outset. If there is a difficulty for quantum, it is because it's actually quite inherently complex in a way that other technologies aren't. Feynman himself did say that if you think you understand quantum, you just don't get it. So it is fundamentally has a mystique of being difficult and complex, and that's going to be a bit of a hurdle. I think the takeaway from today is the need to understand a really complex and emerging scientific field, and to think about how it rapidly moves from being a complex and intrinsically interesting piece of science to something that has major impact on people and the consequences of it, and they need to synchronise those so that they can happen together rather than completely in isolation. And I'll just end that off with, in a decade's time, will my successor be advising a minister as to whether they should have mandatory regulation and enforcement within the quantum sector?